All right, well, I'm actually very excited because now I have 50 minutes to talk. I won't use that time though. As Max was saying, I didn't want him to read my whole bio. That doesn't make any sense. I do security visualization, and some of you might have seen me before. If we look at, it's actually interesting, I think the two talks before me were a perfect introduction to what I'm going to be talking about. If we look at how we're doing security today, it's very interesting, right? Most of the tools, we're actually going back and look at how in the past hackers or adversaries have broken into our systems. And then we take that knowledge and try to apply it today. So like any system out there, IDSs, firewalls, malware, sandboxes, it's basically that. We're trying to take what we learned from before and then apply it today. Now, what I want to talk about is something that I've been advocating for many, many, many years, which is the data that you have, the systems that you operate, you want to understand them, and then based on what you learn from those systems, hopefully you find the attackers coming in. And I've been using visualization for that for a long time, and I will motivate a little bit why I think that's the right tool. It's very interesting when I first started talking about this topic of exploring your data and looking through it, people looked at me funny and they're like, are you kidding? It's way too much data. It's too complicated to look at. We don't understand it. Today, though, there's a job role called the hunter. So you can go and you can actually apply for hunting jobs now where you hunt through the data and you do exactly that. So that's what I want to talk about a little bit. I have 3 sections. I'm going to start very briefly with talking about threat intelligence. It's a very, I guess, modern topic right now. Everybody's talking about threat intelligence, right? Especially in this community also. I want to show you a small process where I sort of extend the idea of external threat intelligence that you get with IOCs, like all these indicators of compromise, on how you can create your own internal threat intelligence. And then I want to briefly talk about visualization, why visualization is one of the key methods of actually looking through your data. And then I'm going to give you some hunting examples and maybe some words of caution also. Starting with threat intelligence. What I just said earlier, if we look at all these different security solutions, firewall, IDSs, web application firewalls, antivirus, most of them we learn from past behavior and then apply that going forward. And that's just something, even with threat intelligence, right? We're trying to learn what are bad IPs out there, what are ND5 checksums of files that are malicious. So basically just learning from the past. But if we look at how attacks actually happen, this is not a number I came up with, but if you look at the Verizon DBIR report, 70 to 90% of malware samples are unique to an organization. So that means if you get attacked tomorrow, then that's most likely a new malware sample that you're getting. It's not the same as before. So we have to start thinking about how we can approach that problem from a different angle. We can't just go and learn from the past anymore. Now, who has heard the security data lake, or the data lake in general? Quite a bunch of people. This is something that in the sort of IT environments, people have started talking about data lakes for quite a while now, especially with the advent of Hadoop. Everybody said, well, you know, what we need to do is collect all the data in one place and then let everybody process it there and use it for all kinds of different things. And that's the same concept that slowly in the security realm we're also starting to do. We're basically dumping all the data that we have into this humongous data pool, kind of like David was showing us with his petabyte of disks that he has to shred every year, right? So we're collecting all this data in one place, and this is really nothing new. We have been doing this for 15 years with the security information and event management tools, the SIMs out there, right? The ArcSights, the Q1s, the Nitros of the world. We've been doing this for quite a while. But there's a couple slight differences here, and I want to highlight those. One of them is I put a high emphasis on context. What I mean by context is if you look at what we're collecting data-wise, right? We have net flows, we have firewall logs, and these data sources have IP addresses in them, for example. And an IP address is something very untangible. It's like, what is this thing? Is it a web server? Is it a desktop? Who is using that system? And what I mean by context is really anything that enriches that data. It's what's the role of the machine, who is logged in, what's the DHCP, what's the MAC address, and what IP address did it have at what time, all those kinds of things. And we need to start collecting that to make up the picture of what's really going on and to understand that picture. The second piece is the data lake itself. And if you're interested more in the topic, I wrote a little book for O'Reilly. It's 30 pages. You can download it for free on the web, where I outline a little bit what is this data lake about and some of the challenges that are associated with it. But you will find all kinds of buzzwords like Spark and Hadoop and Elasticsearch, a lot of the things that you have heard David talk about also. And if you start talking to people here, Lucas was talking about it in his environment that he has a Blue Code also. Pretty much everybody is operating these kinds of systems today, and they're very young. They're 2-3 years old, and they're not that mature yet. But we're starting to rely on them for production and for really critical tasks. So there's a lot of things that we have to start digging into. Now, if you're leaving the architectural layer, and we start thinking about, well, what is this hunting thing all about? The idea is basically, well, we dump all the data into this data lake, and then on top of that, we add a console, a way to actually dig through the data. In my past life, often people started, in big organizations, they start building these big data clusters and Hadoop clusters or whatever, start collecting the data. And then I usually would get the call and they're like, hey, Rafi, can you come help us? We have all this data, what do we do with it now? And that's really this part here. Well, we need to somehow investigate what's in the data set. And what I've been doing for a long time is trying to figure out how do we take that data out and let the user interact with the data and find insight in it. And one of the ways you can do that is obviously through visualization, but it's not the only thing you need. You need a couple of other components, and I'll go into that a little later also. But one of the core pieces here is also technology is not the final solution to this whole thing. It's not that you just apply an algorithm to the data and poof, here is the solution to it, and you find all the attacks that are happening to your network. There's a lot of involvement of humans also. I have a couple more slides here where we need to enable the analysts to look through the data to find interesting things. The machines will never be smart enough, and this is a very bold statement, but so far I've been right, to find all the attacks in our systems, because these things get so complicated, our systems are complicated. The machine can help us and assist us finding those, but they're not the final sort of judge of what's really bad and what is not bad. So what we're doing with this process, if we have this way of hunting, and I will show you some examples of how that can look, you can find hopefully the novel and advanced attacks in your system. And now, the other thing that is happening, by going through this data, I call this internal threat intelligence, where basically you learn about what your systems should be doing and what the signs of normal are inside of your network. And that internal threat intelligence you can then feed back into your system. So you create this feedback loop where you update your rule system to now detect these things again in real time, or you add more context so you learn that, oh, this is our DNS server that everybody's using. And this is, you're creating this feedback loop. The interesting thing now is we're learning from our environment. We're looking at our data. It's not a vendor that publishes a signature. It's your environment. So you're learning about your systems. And there's just no way to get around that. There's a couple other pieces you can use this knowledge for, and one of them is if you sort of run the data sciencey parts. These are all the buzzwords that you've been hearing about: the machine learning, behavioral detection, artificial intelligence, which I think is voodoo. All these different like scoring and so on, where you basically process the data, and with the knowledge that you're gaining from investigating your data also, you're updating these algorithms to get better and better in really detecting malicious behavior and not just statistical outliers. And then hopefully, once you learn from there, you again feed that back into your rule system so that going forward, if that happens again, you will actually catch it again. All right, so this is all kind of hand wave architectural, but how does this all apply to hunting? What I want to do first is briefly motivate why visualization is going to be a key component of all of this all. So visualization itself, who has done any visualizations of security data themselves? wow, that's awesome. I think if I asked this 4 years ago, it was barely any hands. Now it's like half of you. That's great. Who knows Edward Tufte, gentleman here? Has anyone taken his class? Oh, a couple. If you ever have the chance and you're in the city where he's giving a talk or teaches his day-long class, I can absolutely recommend it. It's a very interesting, different way. He doesn't use a single slide for the whole day of class. He has some videos that he plays, but he's absolutely against slides with a lot of text and things like that. So an interesting guy. I encourage you to read more about him and what he has been doing. But one of the things that really sort of made a big impact on me is this one thing he said. He said, how can we see, not to confirm what we already know or what is common knowledge anyways, but to learn. We want to visualize the data so that we can learn something new. And that's what we're trying to do. Now, here's an example of a recent engagement that I've done for a fairly large organization where we took about 100 gigabytes of network traffic and we're trying to figure out what can we do, what can we learn from this data set. What you're seeing here, over time is going to the right, and to the top we have destination ports. And these are just network connections, and every port that is being contacted is a dot in here, right? So you see that there are certain interesting port scans that seem to be showing up here, like the brown line here, like almost halfway through, right? There seems to be something that accesses all of the ports. That is very, very visible, but it's also something we probably don't need visualization to find that. We can probably write a signature and say, well, if in a certain time frame someone pokes at more than, 25 ports, then it's a port scan, and then flag that. You see a bunch of horizontal lines also. That's probably just service ports that are constantly being used, right? Port 80, port, 161 for SNMP queries or something like that. But then there's something else that you might see in here. This is a week worth of data. And towards the right, it gets more and more blue. So there's some emerging pattern happening here towards the end of this week that we tried to investigate what was going on. It actually starts sort of over here in the middle of the week, and then suddenly it gets more and more intense. We tried to investigate this, and we couldn't really figure out what it was. We didn't have enough time. And the problem was also, this is a network with about 200 or 2,500 subnets, and you can imagine how many people are responsible for these subnets and the applications that are running in there. It's really hard to sort of track down what is going on here. But what I want to show you here is visually, it's very apparent. Something has shifted here in the network. Writing a signature for something like this, writing an algorithm to find this is really, really hard, especially if you don't know something like this happens. And we had no clue. We visualized it and we're like, what is this? And it's very, very apparent. It's not like something very hidden here. So visualization can really help. Another way that visualization can help is, for example, here, and I don't expect you to be able to read anything on this slide. What you see here is on the left-hand side is a whole bunch of SQL queries. On the right-hand side, it's the visualization of this data set. And it actually summarizes all of the queries from the left-hand side and many, many more. So what I'm trying to show you here is that this one visualization is really as good as many, many, many SQL queries that you could write. Fact, actually, this is also this data set that I analyzed, and I had it in a SQL database, and I literally wrote most of these queries to understand the data set manually, and I got the result. I'm like, oh, interesting. Okay, there's this many distinct source IP addresses, but then how many distinct destinations do they talk to, and what's this relationship? And at some point I'm like, wow, I'm just stupid. I need to visualize this stuff. So you don't have to go manually through the SQL queries, but you can use something like a parallel coordinate that I'm using here on the right that summarizes that data. And then if you have interaction, you can also start investigating the data on how the relationships pan out. So now I hope that I convinced you that visualization is really important and can actually save us a lot of time. If you agree with that, then we can try to move into hunting. And there's really sort of two base components to be able to hunt. One is you have to have the technical architecture to do it. You need a scalable system, something where you can dump the data into it that you need, and then being able to query it very fast, so you need to have that interactivity. You need to have a way of getting to the data very quickly. If I have to wait for the process to scan through a petabyte of data on disk, that's just not going to happen. You have to have the right data structures. So you need the right kind of capabilities in place to do this, and that can be an incredibly hard challenge. I mean, if we ask David how hard it would be to interactively explore his data set of 3 petabytes right now, it's probably almost impossible. We would have to be very specific on the things we would want to look at. So let me give you an example here. The projector is great, I love it. So this is a graph where you see nodes that represent users and SharePoint servers, so file servers basically. The users are red and the file servers are blue. And you see there's certain connections when the user accesses the server. You can probably sort of make out some of those different connections here. So you could now start to analyze, is there clusters of certain users going to different machines? And if you look at this, there's really not, you probably don't see anything super interesting or that sticks out in any way that would be worth investigating, unless you would actually know what these different IP addresses are. Maybe then you could make some other statements. But if we now take context, what I mentioned before, if we have more information about our users, more information about where the machines are located, maybe that helps. So what I'm doing here is I'm going to go into the HR database and I'm trying to figure out what kind of users are here. And I just use 2 different groups of users. I'm looking at people that are located in our San Francisco office and people that are remote. People from San Francisco are green, the remote people are red. If you look at the graph now, without even being able to see the different connections, what do you see? There's one red dot, right? So there's one remote user, which seems to be very, very anomalous in this graph. So we can hone in on that and start understanding, what is this guy doing? Is this normal? Maybe someone is traveling and uses a VPN to get into the file server. But using the context, we are very quickly able to focus our attention to something interesting in the graph. And we can play with that, we can take other contexts and investigate this more and more. So that's sort of one example. Now, you will hear a lot of talk about machine learning out there. Like right now, this is the hot topic. Every startup is using machine learning for something, right? And then maybe if you're hanging out too close to the Silicon Valley, you've probably heard of deep learning. Everybody's talking about deep learning today, new machine learning algorithm that solves all of our problems. Yeah, okay, good luck. Well, I've tried many, many different things, different algorithms on the data, and I'm sure you have as well. There's all kinds of ideas that people have, like, if we could just do this kind of analysis on the data, and we apply this random forest here, and we do some k-means clustering there. What I found is simple works. Simple statistics will get you great results. Look at the distinct number. If I have to study a machine and learn its behavior, I will look at how many sources are connecting to it, how many machines does it connect to, how many ports is it being contacted on, how many ports is it using out there. If that changes in some way, I probably have an anomaly already. Those are very, very simple statistics you can run. And then you can get into details of maybe time of the day, or what days is it active, and what's the profile for a day, and things like that. But the simple stuff generally works. So you don't have to start with the complicated data science algorithms. And what I'm showing on the bottom right here is actually some of these metrics. Again, you see a week worth of data, and you see that there's during the week, these 5 days, you have very nice daily spikes. On the weekend, it's more flat. And then you very quickly see there's one outlier again, right? That's on the second graph from the top there on the left, there's one huge spike. So whatever metric I'm looking at there, that's something I probably want to investigate, because that's just an anomaly during the week, that spike. And maybe those spikes are normal in the grander scheme of things, but here it definitely sticks out. So here's maybe a little more in-depth example. What I'm using here is actually 2 different algorithms to cluster network traffic. The first algorithm is called TSNE. It's a multidimensional projection into two-dimensional space. If you are doing data science and clustering work, I recommend looking at this algorithm, T-SNE. It's a very interesting algorithm that yields very, very good results for a lot of the clustering approaches. But then what you see on the left here is sort of different groups of IP addresses showing up, or different groups of machines. And the second algorithm is k-means. If that tells you anything, it doesn't really matter. It's just another clustering algorithm. And I use that to color the clusters in here. So there's two algorithms right now that are trying to figure out what are the clusters of machines in my data set. And you see they don't really agree with each other. And I actually played a lot of the different parameters for k-means and so on to be fair, but they still don't agree. And you see that there's all kinds of, it should always be one color per group of machines here, right, if the algorithms would actually agree. So you see there's some very interesting problems. Which algorithm do I trust now, and what are the real clusters? And once I find those clusters, well, do they actually have semantical meaning? Just because it shows statistically there's a cluster, can I also say this is now all my web servers and nothing else is a web server? Those are things that you have to then go into away from just statistical views to actual in the data views. Here's an example of something that works really well that I just said. Very simple statistics. What you see here, every row is a different machine. There's, I don't know, 10 machines here in this network that I'm looking at. They all might have very different roles. They might be the same roles. It doesn't really matter. To the right, you have different statistical properties. There is the number of bytes that are being sent out, the number of bytes that are coming in, the number of different ports that the machine was contacted on, the number of different sources that were contacting the machine. Very, very simple statistics. Again, plotted here over time. And you can see some very interesting things. Like here, pretty much the entire column here with that metric was null. It was always 0. That's probably not a good metric. I'd probably throw that away. There's other ones that are pretty much the same. Like in the first column, pretty much all of them are very nice daily patterns. If you look at the last row here, they seem to be always, for this machine, all the metrics are very, very much in line with each other. So if you actually look at this as a snapshot, say every week, you can start very quickly identify if there's an anomaly. If the bottom one, if there's a new week coming in and the pattern doesn't look the same anymore, something has shifted. There's an anomaly now. So this is something that's very simple to generate. It doesn't take much time. It's not complicated, but it can give you real results that you can learn very quickly. So what I generally do with this thing is I pick the 10 most critical servers in my network. I do this. I visualize the data, throw the metrics out that don't mean anything, where it's like 0 or something like that, and then test, just iterate and test things. And then once we find patterns where we're absolutely sure, this is always how it has to be. So if you have a flat line where the number of ports accessed on a machine is always 5 every day, every time, set a threshold. If it's 4 or 6, that's not good anymore. But if you have like changing things, well, you might have to dig in a little more and learn what the rule is for that. So that's nothing complicated. And then obviously if you like black backgrounds, you can do that as well. You just invert the color scheme here. You guys are really not awake here, huh? I have to maybe script my humor a little better. So another topic that a lot of people are trying to solve right now is lateral movement. So if you look at the kill chain, who threw that up? Someone had the kill chain on here. Was it you, Kevin? No, that was like the other talk earlier. So if you look at the kill chain, right, you have reconnaissance and blah, 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 and then you have exploit at some point. We do most of our detection at the exploit phase, right? IPSs or IDSs and sandboxes and whatever, they try to find when the exploit is actually being applied and compromises your system. Well, a lot of people say, well, okay, we have some stuff in place there, but the stuff that gets through, what do we do then? Well, you want to now check whether there's lateral movement from this first initial infection. Well, is that attacker going to move laterally in the network? And there's a lot of emphasis right now on detecting that kind of lateral movement. Well, so I jumped on that bandwagon and I thought, sure, let's see if there's any weird network crossing. So there's 2,500 subnets in my data set. And I said, there must be like certain ones that always talk to each other, and others that there's never kind of communication between two networks. And I thought, well, this is going to be pretty simple. Yeah, right. So this is the graph that shows up, a complete freaking mess. I have no idea what networks or what machines should actually talk to each other. I thought there were going to be very clear clusters in here. But you can start playing with this graph and it's this hairball. It's a mess. So that really didn't work. So then I pulled out my old statistics book and I was like, I'm going to get to the ground of this and I'm going to apply all kinds of stuff. I'm going to do social network analysis with all kinds of betweenness and centralities and eigenvector whatever things, and then do some seasonality detection because over time there might be something changing and there might be interesting stuff in there. Let's do some entropy stuff and maybe some freaking pattern mining and maybe some whatever, right? And it got really complicated very quickly, and that stuff, again, it just didn't work, and then I couldn't code it right, and like all this kind of stuff. So I threw that away. And then I thought about the problem again, and I said, you know what? If I take that crazy graph, and I try to abstract it somehow, instead of looking at individual machines talking, let's go a level higher, maybe networks talking to each other. Maybe even higher. Let me classify those networks. So instead of 2,500 networks communicating with each other, right, you get this crazy matrix of what talks to each other. Well, can I classify the networks? I have networks that are VPN access, right? People come in, this is a range that is used for VPN. There might be other ranges that are highly critical machines. There might be machines that are my guest wireless access or something like that. I came up with like 16. And I thought, well, now, maybe if I abstract it that way, I see communication patterns. And this is the graph I created. This is called a chord diagram, where you see on the outside, there's these different sort of sets of IP address ranges, right? Like on the top left, I have like office address space. On the bottom right is Amazon Web Services address space, or I have GIA, the guest internet access there. And I looked at this and I'm like, wow, this is a little better, right? We can see certain patterns in here of the different networks talking to each other. But it was still, it's still kind of a mess. I can't really tell what's malicious in here. And this was a very big learning for us in this project that we ran. It's like, we can have a hypothesis and we get to a decent result like this one here, but then we have to start investigating. We have to drill in. We had to look at pretty much every one of these connections here and figure out why does it happen. And we used some heuristics, right? We said, well, okay, there's actually one of these networks that I didn't label is a secure network, where that's really where like financial systems are sitting. And we said, you know what, someone from VPN should never ever go to the secure network, right? Or just sort of other policies that we set, and then we started investigating that. But guess what? There was always a freaking exception. There was like, oh, no. We actually have a vulnerability scanner that is placed in the VPN network that scans these things, and there's an exception in the firewall that allows that to be happening. So you have to go in, and what you do is to start documenting these things. And you start basically building whitelists and say, oh, this is actually normal. Certain other stuff that we found was like, ooh, this is gray area. These really shouldn't happen. It's not a compromise yet, but we need to clean this stuff up, right? So it's often a cleansing exercise as well, so you can actually collaborate with your IT department to help them cleaning some stuff up. But then over time, what you're doing, you're building these whitelists, and you're getting to a place where this graph actually looks much cleaner. And what you do then is you start looking at that graph again over time, and if it shifts in a significant way, then you can say, now I had a shift in my network, and I might want to investigate certain parts again. So this is just a little bit of a glimpse into some of the work I've been doing and sort of what I have been helping customers with. If you're interested in diving deeper, I'm teaching a class at Black Hat. Shameless self-promotion. End of July in Vegas, so check that out if you're interested. And otherwise, I didn't use my 50 minutes. But if you have any questions, I'm happy to take. Max.
Yeah, I have a question. about the cluster analysis stuff, one of the things that I have done is I sort of accept that sort of zen that there are an infinite number of cluster solutions. And basically, you have this huge sea of really crappy solutions and a few little islands here of good, interesting solutions. And one of the things we used to do, and still kind of do, is we'll take those sort of voodoo statistics that clustering systems use, like cubic clustering criterion or pseudo-F or pseudo-T, and we'll scan that huge sea of crappy solutions and pick out the islands using those criteria, and then visually, manually inspect those little islands and say, okay, here. So would you find that as an acceptable strategy?
Yes, yeah. I think everybody heard what Max was saying. It's actually interesting. I've been collaborating with a university in Spain a little bit, where we were saying, it's great to run an algorithm and then have some output, but now we need to investigate that output. And having a visual tool that lets you investigate the properties that are making up a cluster, that's really the key in the end, right? I want to know, why does it cluster? Is it what are the properties that pull something together? Is it the amount of bytes transmitted, or what is it? And is it discriminative against the rest? Because I really want to, ideally, I want to find a cluster that's mail servers, DNS servers, web servers, desktops, hopefully the servers cluster in a certain way. You need to investigate that in the end. And that's often also why these data science algorithms are sort of like black boxes. So you don't really know what they did. They create some kind of an output, often textual, that describes the data in a certain way, but you need to investigate what it is. Right. And that's often forgotten. People are just like, yeah, we have this clustering algorithm and it clusters our data into a certain way, and that's kind of it. So yes, but I actually haven't really seen a tool that would allow us to do that. Because it's not always easy, because sometimes the transitions or the clustering is not linear. So how do you actually go the other way back to the features from your cluster? Yeah, if anyone has done any work in that, I would love to hear about that.
Okay, thank you. That's a good answer.